Hey everyone, I'm Sebastian. I go to Cornell University. I study social psychology, and this summer I'm lucky enough to be working at Bell Labs with the social dynamics team. Today I want to talk about a project that I think is of interest to all of us. It's kind of at the intersection of psychology and information science. So let me just start by talking about sort of a typical day in most of our lives, I'd say, which is just constantly mediated with devices. So we wake up often to our smartphone's alarm, then we'll look at some other device, like let's say a sleep tracker. We'll roll over in bed and check it. We get our breakfast, maybe we enter it into a calorie counter, and so on. You know, we go immediately into work and check our email, and then spend the rest of the day on the computer. So I think this is the top bar over here is sort of, I think, a very standard rough approximation of how psychology works. You know, you get some input from reality, it goes through your brain, and then you make a decision. I think the bottom bar reflects more of our everyday experience nowadays, where the input and the output is just mediated by devices of all kinds. And this is something that's come to the attention of the public generally, and there's now increasing interest in the extent to which real deep human decisions here, like medical decisions and judicial decisions, can be outsourced or done in conjunction with computers and computational methods. So that's sort of the motivation of our project. And in our project, we're specifically focusing on how computers and humans perform at lie detection. So we're interested in lie detection, but also more generally just interpersonal communication, whether people can get accurate signals or not, and how machines can lend insights to that problem, and how humans and machines differ in that way. So with lie detection specifically, though, there's two main research streams that look at it. One is psychology here, so there's some debates in the literature about whether people even can detect lies better than chance, or whether some people are better at detecting lies than chance, or whether groups are better at detecting lies than chance. So the focus is around how people detect lies and whether they can at all. In computer science, there's also a wealth of research looking at lie detection. In that case, the goal is a little different. The motivation is to just get as accurate as possible, to use as many means, methods, signals to get as accurate a lie detection as possible. So here you see a study that even uses thermal images to try to detect lies. So in our project, what we wanted to look at is whether sort of the human mind and a computer, computational methods, could be combined to sort of lead to lie detection that's better, more accurate than either one of them alone. So that's the basic motivation of our project, is to see whether computers and humans can interact in a way that allows them to perform social judgments even better than either of them alone. So now I'll start with the way we researched that. So on the right, you'll see a little timeline, and here's the steps of the project. First, we just get a bunch of statements, a bunch of lies. Then we evaluate performance of computers and humans alone, and in the final step, we evaluate their combined performance, so the two of them together. So in the first step of getting the statements, we relied on the data set from another group of researchers that actually paid 500 people to write a total of 7,000 statements, 50-50 lie, 50% lie, 50% truth. So, and those were labeled to us, so we know the ground truth on each statement, whether it's false or not. As you can see, there's some of them below right there. So in the first step, we just trained a computer to, well, I shouldn't say we, Ava, who just talked probably, did most of the work. She extracted, features of the statements like emotions, topics, complexity, and then trained the model on 90% of those statements to predict truths or lies. And then, we tested on the remaining 10% of the data, the 717 remaining statements. And if we look at that model, we see that the computer can significantly beat chance. So the average performance is around 66%, which is significantly above 50%. So the model that we trained was actually able to beat chance significantly. After that, the next thing that we looked at was how humans did at lie detection. So we basically gave the same task that we gave to the computers to humans. So we gave the same 717 statements that we used in the test set to humans, and we just said, do your best job at guessing whether each of the statements you're reading is a truth or a lie. And then we wanted to see how the human lie detection performance compared to our computer models. And as you can see, here's the result. They're about the same. The human lie detection is a little more. It's about 69% versus 66%, but that difference isn't significant. So at baseline, on these particular set of statements, it looks like the two are actually pretty comparable. So the next step that we wanted to do is basically see, okay, what happens if we combine these two sources? So what we did is we ran an experiment similar to the one before, where we gave the statements to a group of human subjects, and we asked them to predict whether their lies were truth or not, except they were given one additional piece of information, which is the computer's prediction. We told them we trained a model that was better than chance, not perfect, so they could incorporate that information how they saw fit. If they weren't feeling confident, maybe they could take it in. If they felt confident, maybe they could trust their own judgment more. We thought that would lead to higher accuracy. As you can see here, it doesn't. It actually went down a little to 66.5%. Again, that difference isn't significant, but it's an interesting finding that people didn't seem to be able to integrate those two pieces of information in a way that combines them to improve their accuracy. Their accuracy basically stayed the same. And then the final thing, major thing that we looked at is doing the sort of the same thing except for computers. So we got a group of crowdsourced workers to make a prediction for all of the training set data. We trained the model on all the features it had been using before, plus human predictions, and then again we tested on the same test set to see whether the computer could incorporate its own methods and the human predictions to have higher lie detection performance. And as you can see here, in that case, we did find this result where they could combine to be better. So the computer using human predictions and its own judgments got 75.7% accuracy, which was significantly higher than computers alone, or than humans alone, or than humans and computers. So humans and computers could combine, but it was when the computers made the final judgment. And we also conducted one final edge case final experiment where we gave humans the same task to incorporate the computer's reasoning, except unbeknownst to them, we gave them the predictions were 100% accurate. We wanted to see how that happened. In the ideal case, could they successfully incorporate a 100% accurate computer? And as you can see, they were only at 72%. The computer, obviously, when it was given perfect information, picked it up and got 100%. So the main takeaway of this study is that, yes, humans and computers can work together to spot lies, but only if computers make the final decision. Now, it remains to be seen whether this generalizes to other social contexts and other social judgments. That's a very complicated question, but I think one that's of interest to all of us to see. Maybe there's some way for computers in general to aid us in our social judgments. Okay, thank you for your time.